If you have any questions, feel free to use the chat, or if you want to unmute yourself and speak out a question loud, that also works for us. Right, so we've seen this figure. We're considering multiple stakeholders in the marketplace process. And in this part of the tutorial, we're going to talk about a few case studies. So we're going to look at 7 case studies. We're going to look at families of objectives and understand the interplay between different objectives. So these could be correlation analysis. Some objectives are competing versus supporting objectives. So let's just take the first case study of Uber Eats. So Uber Eats is a 3-sided platform. So we have the eaters who want to discover and order food through the platform. We have the restaurant providers for which it's a sales channel, because you can be on Uber Eats and you can find new customers. And we have delivery partners as the third stakeholder. So delivery partners can earn income by picking up food and delivering it to the eaters. There's a very nice blog post which kind of describes this in a lot more detail. I highly recommend you reading it. The nice engineers at Uber Eats has given their nice thinking around how they evolved their framework over a period of 2 years. If you look at Uber Eats as an example, then if we don't have enough eaters, the problem is restaurants won't participate. If we don't have enough restaurants, then the selection available to me as a user decreases. And if the order decreases, then the delivery partners earn less. So that means an unbalanced market demand supply dynamic degrades the overall experience. Which Uber Eats provides as such. So essentially, if we convert these into some specific objectives, then a few examples could be the eater conversion rate, that we want to convert a user from not just a visitor, but also a user who kind of converts and orders something and comes back and orders again. We want to increase the diversity of the platform. So diversity could be based on the variety which eaters can explore. We want to understand content based on the exposure of restaurants. We want to increase the earnings per delivery partner. We want to optimize for pickup times and distances. We want to look at delivery times as well. Quickly going on to the second example. In the second case study, we can look at some on-demand delivery solutions like Postmates or Instacart. So in here, it's again a 3-sided problem, wherein we have users who can order anything from local partner shops. We have merchants who provide online visibility. The platform provides online visibility to them. We have delivery partners, and the delivery partners can work and earn on their own schedule. So again, typical, as is the case for Uber Eats, we have different objectives here, and the objectives could be that the users want quick delivery. So we want to consider the time to delivery as an objective as well, perhaps. We want to consider the prices, like some users are not willing to pay a lot and some users are. The freshness of items, we want to expose only reliable merchants to users. So essentially, even looking at user-centric problems, we would want to consider multiple objectives like these in order to decide what kind of restaurants or what kind of retailers we want to show in front of users. In terms of, let's say, delivery partners, we care about giving them some regularity in jobs. So we don't want to have a recommendation model which only gives you one delivery job every day or every week. That's not very regular. So there's going to be problems around earnings there. Again, we want to be very efficient in the drop location planning. So you don't want to bring somebody from 10 kilometers away or 10 miles away to make a delivery like 5 minutes away delivery. So again, when we are deciding on what delivery partners to pick up, we have to consider multiple of these things. And this in turn should kind of govern what kind of retailers you show to the user at the top. Let's look at Etsy, which is a marketplace for craftsmen. And it's a huge marketplace. They've been thinking about multi-stakeholder problems for a while now. And here, again, it's a 3-sided marketplace. You have the buyers, you have sellers, you have the platform itself. The buyers choose the unique products. Sellers can reach the larger audience, and the platform can kind of speed up the process between the buyer and seller communication. So in terms of Airbnb, it's a 2-sided marketplace wherein we have the host who are looking to rent their space, guests who are looking to buy a place per stay. And again, it's pretty huge because they have close to 6 million plus listings, about 500 million plus Airbnb guest arrivals. There's a very nice Medium blog post around the machine learning powered experiences in a multi-sided platform like Airbnb. So this blog post gives a nice summary of the objectives which the search team considers when they decide on what kind of homes and stay locations to show to users. So some of these examples are conversion, that we want to kind of convert the user from a search to a booked user pretty quickly. So there we care about like booked experiences, things which we have clicked but not booked yet. Other objectives are the number of bookings per host. Like we want to look at, like, let's say some global popularity, but also there are often tail hosts. So hosts which never gets any booking, that's not really good for the host. Again, like some things which Airbnb also considers is different objectives for low intent users as well, and also like helping hosts who host less often but come back from a vacation. So again, like not all hosts are equal, right? I mean, if you take your property away from Airbnb for a while and then come back, then you want to ramp up quickly, and the model should consider that as an objective separately, perhaps. In terms of Spotify, we care about connecting users and artists in a meaningful way. And here our stakeholders are not just users, but also artists. So we want the artists to earn, we want 1 million artists to earn living from their work on Spotify itself. So again, we view ourselves as a multi-sided platform as well. In terms of P2B lending, the platform connects investors who lend money directly to individuals and businesses. So Funding Circle is a typical example. And in Funding Circle, again, it's a peer-to-peer lending marketplace. And when you're thinking about lending, then it is, we have multiple different objectives. So first, we want quick and easy access to loans. So in that case, what we want to do is, like, if I want to give some money and lend some money on a peer-to-peer platform, then I want the platform to show specific users who want to borrow money based on my profiles. So I want a good return on investment. I want a better matching between me as an investor and somebody as a borrower. Again, like we want lower loan default cases. We want to increase the number of borrowers. So in general, these are the potential objectives which you might want to consider when you show different funding opportunities to investors, or different investors to the people who add their campaigns on these peer-to-peer lending platforms. The last example I want to show is a crowdfunding initiative. So crowdfunding is pretty nice, and there are different flavors of it. Some of it could be Kickstarter based. Some of these might be more health and immediate need based. So again, like this presents a very interesting case study in front of us, because which one of these would you decide to show at the top of your homepage, right? In the sense that, like, you have a very fancy drone camera, which costs a lot of money. You have some art, or you have a very specific health need. Now, we have to be very careful in terms of deciding what kind of objectives we want our platforms to optimize. If time urgency is the objective, then we would want to pick up campaigns which are more time sensitive. Whereas, like, again, based on user needs, some users would prefer art, some users would prefer fancy tech stuff. So again, like, we have multiple varieties of these campaigns, and it really plays an important role on which objectives you consider in your modeling process. So time to success for the campaign, amount raised per campaign, the number of successful campaigns, and like success rate per category. These are all important aspects which you might want to consider. There's a very nice paper at Wisdom 2016, which kind of looks at some of these and talks about project success in general. So that's hopefully that has given some understanding of what kind of objectives, what kind of stakeholders we are looking at. Now, with that context, what I want to do is, like, I want to go in a bit more technical and talk about how these objectives are related with each other. And this background and this motivation will help us to develop appropriate multi-objective models in the third part of the tutorial. Okay, so just a quick time check, and if you have any questions, feel free to. I see Ben is thankfully answering some of those questions. Yeah, feel free to drop in or unmute yourself and ask questions as well, if anything works. Okay, so if we talk about different objectives, so just looking at these 7 case studies, we have seen that there is a nice sea of potential optimization objectives. So each of these is something which you can quantify and then optimize for. So in general, we can talk about these in terms of families of objectives. So they could be a user-centric family, which could include things like user satisfaction, variety, serendipity, diversity, the amount of fund raised, delivery time, supplement prices. They could be supply-centric objectives, which is like we want to expose the different suppliers. They could be content-specific aspects like diversity, freshness, fairness of content exposure. And there could be platform-centric objectives, like some objectives which help us ensure that the platform is healthy and sustainable in the long run. So in general, quick thinking on how some of these objectives could be computed. So some of these could be like really static computations, like let's say relevance. So in relevance, we can look at a user, an item, learn some representations and compute some similarities. So we need not train a relevance model. We can just kind of look at some existing vectors and do cosine similarity and get some of these scores. We can look at familiarity of users. So I mean, how familiar some users are, some examples of things like time to success. So we don't need to predict time to success. I mean, we just want to measure time to success. So the point over here is that some of these computations can just be estimated using the data you have. While oftentimes we want to predict things as well, like the probability of click prediction or the probability of consumption, the probability that the user will save this music or save this movie, the probability that the user will return back. So all of these are targets which can be predicted. So not only in the first case, we mentioned that some things which we can just compute using the numbers and data we have, but we can also develop prediction models. When we're developing prediction models, we can either develop a single task prediction model, like a typical simple ML model, or we can do multitask models. So we're gonna come back in about 20, 25 minutes and talk about these multitask models in a bit more detail. And finally, some of these could be just factual. Like, I mean, the objectives need not be predicted. Maybe this is, you signed some deal with some of your retailers, and any product you sell on Amazon from that retailer, maybe the platform gets $1 each based on the products you sell. So they could be margin-based, they could be revenue-based deals, which kind of govern how you kind of, what kind of objectives and how they're quantified, essentially. So there's a question on what's the difference between relevance and familiarity. That's a good point. So just an example. So let's say we derive some vector for you as a user, and let's say we have an item vector as well. So relevance could be computed as a cosine similarity between the user and the item. Now, I need not have consumed that content before to get a high relevance score. Maybe it's just a very nice content which I just haven't come across yet. So that is a relevant content based on my taste, but then I'm not familiar with it yet. So familiarity could be something like, I've seen this, I've listened to this music 10 times, I've watched some of these series, some of these actors a lot in the last 2 months, so I'm very familiar with it. So that's the difference. Like relevance is kind of an indirect signal that we think this is relevant based on the computations of vectors. Familiarity is like a thing which we can kind of compute based on how familiar user is. How do we define affinity? Good point. Again, like we're not going into specific details, but affinities could be, again, I'm going to come back to some of these on how do you define some of these objectives. A quick example of affinity could be like, let's say you have streamed some music in the last 1 month and you really like that music and you've never skipped it and you've saved that music to your playlist as well. So that's a positive affinity indicator for us. And let's say if you watch a movie or if you watched an ad and you've always hated that ad and you've kind of blocked that ad, that's kind of a negative affinity. So we can define affinity based on, let's say there's a specific movie genre you like a lot. So you always go and look for that genre. And that's like you have positive affinity to that movie category. Or if you always hate when Netflix recommends you those type of movies, then that's like a negative affinity. So again, like we can be very flexible in how we define some of these affinities and familiarities and relevance. But the point is some of these models, right? I mean, some of these objectives, they could just be an output of an ML model. So if you look at the case in between, the predicted things, these are learned models. So there's a model which learns some of these features, and that's the objectives you want to kind of optimize in your model. So an example, nice example here could be return rate. So we want the user to come back to the app often. So what we want to do is like, we want to predict whether if we show this content, does the user has a high chance of coming back? So return rate in like 7 days or return rate within a month. So these are things which we can predict and then optimize for it subsequently. So this goes under the predicted via learned model categories. So there's a point, even a dot product based relevance is still a model. Yes. So again, like relevance. So relevance is a dot product, and again, like you can train models to get your vectors. So yeah, I mean, it really depends on like where you're drawing the line. I mean, if you have a model to predict something in real time, the real time could be like the probability of the user clicking this item based on the context we have. That's more of a predicted model switch I'm talking about. But essentially, like yeah, theoretically, you're right. I mean, all of these are models essentially. Okay, so going forward, now we want to understand the interplay between some of these objectives. So now we have a sense of what some of these objectives could be, and let's see, okay, what's going on in between those objectives. So again, typically, exhaustively, there are three types of relationships. So they may be correlated. And if they are correlated positively, then if you optimize for one, you're going to help the other. They may be neutral, like if you optimize for one, it does not impact the other at all. Or they could be anti-correlated, like if you optimize for one, you're going to hurt the other. So let's take a step back and look at some concrete examples. So we had a paper at SICM 2018 looking at the counterfactual evaluation of the trade-off between relevance and fairness. So let's say we have two objectives. So we have the relevance of some playlist to the user, and we have the fairness / diversity of the supplier. So some playlists could be really diverse in terms of what artist they showcase. Some playlists might be not as much as diverse as others. So if you look at the plot on the right, the y-axis is the fairness estimate. Like fairness is, let's say, a version of diversity. That is this playlist having a high diversity across artists. So playlist which has artists from, let's say, middle tier, middle of the distribution or tail distribution, head of the distribution of the artist exposure. A playlist like that will have a high diversity score. A playlist who's really picking artist or content only from, let's say, the head of the distribution, then that playlist or that content may not be very diverse. On the y-axis, we have relevance to the user. So these are these content which how relevant they are to the user. So an important thing to note here is the void at the top right corner. So this void says that very, very few sets have both high relevance and high fairness. So this fairness is the fairness of exposure, that are we exposing suppliers in our sets? So this is a very interesting problem because this kind of projects a conjecture that if you optimize only for relevance, you will end up hurting diversity and fairness. Because had we had things at the top right corner, then that's perfect. I mean, this is relevant to the user. This gives us fair diversity to the suppliers as well. Let's recommend that. But no, that's not the case. I mean, there's a strict trade-off here. Let's go beyond just two objectives. Let's consider like multiple stakeholders. So let's say we have three objectives from the users. We have the stream time, we have clicks, and the number of items they have consumed. We also have diversity, like supplier diversity. And let's say we want to promote a set of suppliers. So you could do sponsor search on Amazon or Google sponsor ads. So there are other ways of promoting suppliers as well. So if you consider these 5 different objectives, then we see that different SAT metrics are correlated with each other. So that helps. Like I can only optimize for one and the others would at least benefit slightly. The supplier diversity is almost neutral with SAT metrics. So I mean, regardless of what you optimize for, whichever SAT metric you optimize for, you're gonna not, SAT is satisfaction, sorry. So SAT is the term which we'll reuse again and again, which refers to satisfaction. And this is explicitly user satisfaction. So thanks for asking that. And some of the promotional objectives might hurt users. So an example of SAT objective could be these stream time, clicks, number of songs played. So in general, we see that oftentimes the value is the correlation between those. So this is a heat map showing the correlation between the different objectives. And we see very clearly that the SAT metrics are all correlated, but some of the promotional objectives might hurt your SAT objectives. Now, this is very interesting because this shows that there's no free lunch here. I mean, if you want to optimize for some stakeholders, you might have to incur a cost. So then finding the right balance is very important and is key in this scenario. And this is like a case study from music domain, but let's consider another one. Like let's consider the Uber Eats example. Again, this is the same blog post I mentioned before. And in the Uber Eats example, this blog nicely highlights that if you only optimize for eater conversion, like you want the eaters, the users on your platform to quickly buy food from the things they see at the top, then you're going to favor popular restaurants. And if you favor popular restaurants, then you're going to hurt your fairness, assuming fairness is defined on exposure, that you want to expose the different restaurants equally or in some fashion. Again, if you optimize for marketplace fairness, like I recommend literally every restaurant equally, then the problem is as a user, I get irrelevant restaurants. Just because as a platform, you had to show that tail restaurant doesn't mean that I should suffer and have to kind of put in more effort to find the restaurants I care about. So that hurts eater conversion. So this is interesting because it shows a very nice trade-off between the different stakeholders. There's a good question here. How do we quantify the value of marketplace fairness in the same currency as user satisfaction? This is a very, very important point and very important question, which I don't think has been answered yet. So again, it depends on, so the question here is, how do you ask this question around, how do we quantify, like, can we bring some of the user metrics and some of the artist metrics and some of the platform metrics on the same scale? And is a 0.1 gain of satisfaction equivalent to a 0.1 gain of supplier? It need not be, right? I mean, I think this is a platform specific thing that, and also context specific. Sometimes as a platform, you really care about exposing some of your tail retailers if you're Amazon, whereas certain times you care more about user happiness. So again, like, I think there's no fixed currency, but then like, we need to kind of invest in some research and to kind of further our understanding on how much of a gain in one would be equivalent to a loss in the other. We're going to see some results in the second half of this tutorial around how some of these metric movements impact one another. But yeah, the exchange rate between some of these objectives and metrics is an understudied problem right now. So there's another question around what about deal recommendations? Suppliers may be less important, but user revenue is. User supply deal recommendation. So again, like here, again, this is a trade-off, right? I mean, every time you bring up any specific example, like if you care about deals, user engagement, and revenue, then it's a trade-off which you as a system designer or you as a platform owner will have to make. Like once we can, again, we want models which can use the trade-offs which we tell the model to use. I mean, we control that, okay, no, I only care about users. So I'm going to give the user objectives the weight one. I don't care about revenue. I don't care about anything else. So there, the platform owner is deciding, and the models we develop have to take that into account, input into account, and then do the matching so that we kind of deliver based on the trade-offs given to us. But as a platform, I might care about revenue more than I care about the suppliers. Again, this is, I think, a very case-by-case specific decision. And it's also a very important problem because we're going to look at some of these multitask models and how do you balance between different tasks and different objectives? So do you care about just getting predictive accuracy or do you care about like impacting your stakeholder metrics as well? Just another example. I'm going to come back to the next few questions in 5 minutes after we end this specific part. So this is talking about the interplay between objectives in the Airbnb case. Again, a very nice blog post on Medium by Airbnb Engineering, which consider this. So in general, what they found in some of their offline evaluation and online test was that in general, if you optimize for new hits, so a new hit could be like, let's say there is a very nice home in the middle of London, which is very, very new, very recent. And not a lot of people know about that because it's new. So on the platform, it does not have enough information to kind of get exposed multiple times. So here, if you optimize for new hits, then you will get, I mean, they're seeing gains for booking on the new hits, which makes sense that, okay, there's a new hit. I want to make sure that my recommendations expose new places, new host more than others. So then we get a gain. But interestingly, and thankfully, it was neutral on overall bookings. Because oftentimes some users may not like new places and they might prefer like traditional old places as well. So again, like if you look at some of the other examples on the table, then it kind of highlights that you can make these trade-off decisions based on some diversity-centric goals, some intent-centric goals, and some like optimize for new bookings or not. So again, the takeaway message here being that when you're considering the interplay, it's kind of this interplay exists. Oftentimes, some metrics will help each other. Oftentimes, some metrics will not help each other, or instead be harmful to each other. So in general, there's a question on, can you clarify the chart on the right? Yeah. So the chart on the right gives some gains around adding specific features and the exact gain which the target metric saw on the Airbnb platform. So again, if you add in more experience features, you get a significant gain. If you add in some experience and user features and query features, you get gains as well in your overall bookings. The moment you start enforcing diversity, right? So diversity still helps in improving the overall gain. So that means like some users really want diversity, and if your model is optimizing for diversity in the places shown in the top 8, then you're going to get gains in user satisfaction metric as well. So again, like these are all cases wherein like sometimes again, like if let's say we have a set of promotional places and host to show on the platform. Now, users may not like those promotional posts, and they may not match. Based on user preferences. So then we can expect to see some drop in user engagement metrics as well. So again, this example just shows that like what some of the interplay between diversity and user satisfaction objectives are in the Airbnb case. Also, I think these are not offline numbers; these are actual A/B test numbers. So yeah, so they've been looking at. If you go and look at the details of this blog post, you'll find some nice work around like what kind of metric movement they've seen in their online actual A/B test, which was deployed to real traffic. Oh, okay, somebody can confirm this. This is great. Interesting. Perfect. So again, like the takeaway over here is like what the system optimizes for is very important. And we have somebody from Airbnb Experiences to confirm this. Hi, Puvia. Yeah, thanks for confirming. Again, like if you have any additional points to add in, feel free to unmute yourself and speak out loud. So interestingly, what we see here is like, we've seen like some objectives can hurt, some objectives can help each other out. But then interestingly, it's very, very important to make sure that you are very conscious around what kind of objectives you optimize for. So again, some examples here, right? I mean, let's say some in the peer-to-peer lending case study, which I mentioned, there have been news articles that in general, like some investors and some investors have lended money and their money has gone waste. In general, marketplace as a platform, if they do not consider their own objectives in the recommendation process, then they fail to build user base and never turn profitable. So again, like if you don't consider the platform objectives, then you might not ever turn profitable, and then that's not good for the long-term health of your platform. And if you only optimize for, let's say, user interaction, then we go into the clickbait style scenario and we go into the filter bubble style scenarios. There are cases wherein Uber passengers have waited for hours, or even the Uber drivers have waited for hours. So this news article and this article here kind of shows that if you don't optimize for, or at least be considerate about the waiting time for the Uber drivers as a stakeholder, then it kind of creates a problem as well. So again, just a few examples on why looking at individual stakeholders and caring about their objectives is important, and why it makes sense to consider them in the optimization problem space. So that's the second part. We've kind of, again, the takeaway messages here being that we have multiple stakeholders. And very interestingly, we not only have multiple stakeholders, but we also have multiple objectives for each of these stakeholders. And this is key here, that now we're not only dealing with a multi-stakeholder problem, we're dealing with a multi-stakeholder, multi-objective optimization problem. You've seen the interplay between objectives, like they could be neutral, positively correlated, negatively correlated. And we have to give careful consideration to decide which objectives do our systems optimize for. So that's the end of the second part. I'm going to look at a couple of questions now, which we have skipped. So can we consider optimizing fairness for suppliers equivalent to optimizing for diversity for users? For instance, if the user sees more diverse items, more suppliers will get greater exposure. Yeah, so this is a good point. We're going to come, so Sami asked a nice question, that fairness for suppliers, right? We talked about it briefly. So in terms of fairness for suppliers, we were talking about can we expose different suppliers to you as a user? And this has a role to play in the diversity shown to the user as well. Because if as a user, I expect diverse content, and if you have multiple suppliers to show, then we can be a nice match for each other. So that's true. But then this is not always the case because again, like philosophically, they are very similar that we want to expose different suppliers and users expect different suppliers. But then are they really, like maybe there are certain suppliers you want to expose which are not relevant to the user at all. So any diversity to the user is not good diversity. So just because I see 8 different items does not mean I am happy in terms of diversity. These should be relevant diversities. This should be appropriate diversity. So again, like as long as we are ensuring that there is a match between the diversity I expect and the relevance of those diversity to my user profile as well, then I think it's a good match. But it's a very good point that now we're starting to see that diversity-centric users and supplier diversity are related. So maybe we can combine these two. We're going to come exactly to that in the 4th part of this tutorial and mention a few examples for those. There's a question by Venting on if we can quantify the fairness by satisfaction. Oh, okay, that's an answer, right? Yeah, I think we can directly optimize the sum so that we can have a single task objective. Yes, so that's a good point. I mean, if we can quantify fairness by satisfaction, again, we don't know the ability to which we can do that. Is it like everything on fairness can be captured by everything in satisfaction, or there are certain parts of fairness which will never be captured by user-centric metrics? Again, if we see that they're all related and they can be captured, then we can go to single task models. And that's the scalarization approach, which we're going to come to in the next like 10, 15 minutes. There's a question from, okay, I'm going to scroll through a bit. So whether it's individual stakeholders or objectives per stakeholder, we need systems that can optimize for these things. Yeah, that's a good point. I mean, we can have multiple stakeholders or objectives. At the end of the day, these are all, I still think like grouping of objectives based on stakeholders is interesting because if you have to make trade-offs, so you can make trade-offs at the global level, like across stakeholders, but perhaps you can also make trade-offs within the stakeholder that, hey, I'm not going to give you enough exposure, but when I give you exposure, I'm going to make sure that I give you enough revenue opportunities. So again, like if I know that on Uber Eats, some users tip more and you haven't gotten a ride for the entire day, then maybe what I can do is we can put some intelligence and say that when we give the ride, then the overall revenue gained or overall tip given to the delivery partner on Uber Eats is high. So again, like looking at the stakeholders and objectives does have an element of more rich granularity for us to work with. So how do we compute the correlation between these objectives? Yeah, so again, so there is a way to do this offline. Again, there's a way to do this online as well. Ideally, if you do it online, then you'll be running tests around what if I balance between these two objectives and what kind of happens there. In the offline world, exactly, I mean, specifically the heat map I was showing, that heat map is computed using, so this heat map, right? So this heat map is looking at a bunch of user sessions from, let's say, 1 month period. And for each user session, we know that how many of those items you consumed was a promotion versus how many were given based on diversity and how many you kind of clicked and not clicked. So again, we can look at some of these offline log data and see like, if you have a list of items the user consumed, you can easily compute the satisfaction metrics. And you can also compute the diversity and promotions, whether you're kind of showing some diverse content in those sessions or not. So again, there's a way to compute these using log data, which we did for this case. So there's a question on the Airbnb example. So yeah, so this Airbnb example is like always green, but I think this is just a biased presentation, which I have done. I'm sure like there are a lot of these negative results which the team would have shared somewhere. So Mihalo at Airbnb has been kind of doing some blog posts around that. So I'll suggest reaching out to them to kind of find more. So this is just the public information I have. I have no internal access to Airbnb experiments, so I cannot say more about that. But at Spotify, we do have seen like negative impacts. Like not all objectives are benefiting each other. I mean, we're seeing that if you optimize for one, you're going to hurt some of the others. And there's like strict trade-offs which you need to make. when you're kind of doing all these decision making. There's a question, how did you get these data to calculate correlations? Oh yeah, I mean, so this is like, again, this is Spotify data because we have access to it. But at the same time, so these are not like query logs as such. This is not search data. This is more like playlist consumption on home. But yeah, you can look at search data as well. Also, like we have released 1 million sessions publicly. So there's a data set which was released as part of Wisdom Cup last year. And that has a 1 million sessions from users. And that session, and I mean, this has like user interaction information as well. So whether the user skipped the track or how long did they stream and so on. So that's a very rich user interaction style data set, which is publicly available for us to consume. So I recommend you going and having a look at the Spotify public data sets. We've also released a podcast data set recently as part of the Trek Challenge. So we're putting a lot of effort in releasing public data sets. Okay, I'm going to take this last question and then go back to the tutorial because I want to make sure we start the third part before the break. So Sami asked a question about data for marketplace settings in recommender systems. The question is, as in any online system, data is collected through previous iterations. This may induce feedback loops, biased, and therefore results in unfairness, lack of diversity. How do you ensure that the data set is unbiased? This is an excellent question. So let me explain the question a bit for others. So the question is, let's say we compute correlation analysis, right? I mean, let's go back to this plot here. So let's say if I have to draw this plot and get this heat map, then maybe the model which the data which I collect, that data was result from a model which was running in production at that point of time. Now, if that model does not consider diversity at all, or does not do any promotion at all, then the problem is like, we won't ever see, or we'll very rarely see diversity or very rarely see promotions, right? So there's this like super biasness in the data you have. And there's a whole field, subfield in the online experimentation world. And Ben is one of the experts in that field, is on counterfactual evaluation and unbiased experimentation and inference. If Ben is around, like, again, like feel free to drop by and add a few things if you think I'm missing something. But essentially, as a field, counterfactual evaluation says that, hey, you can go back and maybe do some correction to the data. So you can log the propensities. So propensity is the probability of you taking that action. So when you're collecting the data, if you log some of these propensities, then there is some mathematical work which guarantees that you can get some unbiased metrics computations out from your data. So again, few things you can do. One is you can look at the counterfactual evaluation literature, and then look at ways on how can we use biased log data to come back with unbiased estimates of metrics. Or you can do a randomized study. So here I'm going to present a paper in the fourth part, wherein we did a randomization study, wherein we were randomly showing playlists to the users on the homepage, very small traffic, and then we kind of derive some insights from there. So this heat map is coming in from one of those randomized flights. So again, as I briefly mentioned that if we show enough random data, then we can use that randomized data to get unbiased evaluation metrics. And there's this field around off-policy evaluation, that the model which you are evaluating is different from the model which you use to collect that data. And in that case, we want to do off-policy evaluation of our recommendation models. So there's a very nice line of literature around there. And that says that it would be nice if you can get and collect some randomized data. So these are coming in from such sort of randomized data. So again, yeah, you can look at randomized data, or you can look at biased log data and then do some propensity score weighing. And the specific term to look for is off-policy evaluation or counterfactual evaluation. But great question, very, very good point. Okay, so how are we doing on time? I'm gonna use the next 20 minutes to at least start the discussion on methods for multi-objective recommendations. That's my favorite part of the tutorial. And then we're going to come back to talk about the rest. Right, just going to answer this question. Randomized control experiments be pretty costly? Yes, so they are very costly in the sense that like we might hurt users a lot. So I mean, again, there's a trade-off. that overall, if you can improve the system quality by collecting randomized data, then you do it for the greater good. But also, we don't run it on like a 5% traffic, 10% traffic. I mean, these are very, very small traffic experiments wherein we just launch it to a very small subset of users and then collect that data. But again, these are pretty costly. So that's why you want to make sure that when you do it right. And once you have that data, you milk it the max you can. I'm going to also mention about, so there's a study which we did. Pauli mentioned the great point that like user experience might suffer, but the opportunity cost, the eventual cost could be high as well, because again, if this gets me to evaluate models and ship them very quickly to users, then overall happiness might increase at the cost of short-term loss. So again, there's this nice trade-off between like short-term happiness and long-term gains. So I agree that this is costly, but then like it's very prevalent in the industry. We have to, again, we need not collect randomized data. It's not the only solution. So if you're, one of the other ways is like when you show certain content to users, you log the scores which you use to generate that ranking. So let's say I have a bandit model, which is ranking content. Then I'm going to log the action probabilities. And then I can use those action probabilities to go back and compute my unbiased metrics. So again, we need not always run randomized data. If you're collecting these scores which caused your model to show some of those content to users, then we can reuse a lot of that information as well. Cool. So this is great. I love that fact that we're asking questions and commenting. Again, feel free to unmute yourself and speak out loud as well. I'd love that. So taking a step back,